Hello, welcome back to the channel, and today we're going to be learning about C-frames. What is a C-frame? A C-frame represents the position and rotation of an object, and both are represented by vector trees. What is a vector tree? A vector tree are tree numbers represented by the x, y, and z components. So the first number, the x-axis, is represented by the color red. As you can see, when I move the red arrow, it changes the first number. The second value, represented by green, y-axis, and the third value, represented by blue, is the z-axis. Same goes with rotation. X-axis, first number, red. Y-axis, green. Second number. Z-axis, the last number, represented by blue. Now let's focus on our part position. So usually when you want to move your part, you just get the part.position and then you put in a vector tree value. What this would do is it would get these three numbers and then change our part property here into our new position 0, 5, 0, which, as I explained earlier in our vector tree definition, is the vector tree distance from the origin. As from this visual here, 0 x-axis represented by red, 5, 0 is our vector tree distance from our part. Now, what if you want to move your part relative from itself, or what the wiki calls object space? You have to get the part position, which, if you select this right here, this will give you the part's position, and then you have to add it to a vector tree.new. What this would do is it gets the part position, which right now is, let me make these nicer numbers, 11, 12, and 11. What this would do, what adding a vector tree with itself does is adds each component with each other. So the x component here is 0, adds with 11, makes 11. At 5 plus 12 is like 17, and 0 plus 1 will make it 1. So if I run the script right here, it will move it along here. As you can see, nothing is added to the x-axis, nothing's added to the y-axis, and nothing is added to the 5 is added to the y-axis and something's added to the z-axis, and that's how it makes it. Let's do a more complicated example just to show. So let's add each dimension by 10, and what this would do is adds 10 to each component. Adds 10 to the x component, adds 10 to the y component, adds 10 to the z component. Play. As you can see, adds 10 to each. Now, you can also subtract, and subtracting does exactly what you'd expect it to. It subtracts using each of the components. So if I select my part here, if I use subtract here, minus vector tree, it will take away one from the x-axis, one from the y-axis, and one from the z-axis. Play here. Minus ones to each component. You can also multiply it, and just like minusing, it does the same thing. Since multiplying 1 gives itself, it won't actually do anything, as you can see. But if I multiply each component by 2, multiplies each part by 2, as 11 times 2 is 22, 12 times 2 is 24, and 1 times 2 is 2. And if you just want to multiply each component by the same part, you don't even need the vector tree. Multiplying a vector tree with the number itself will multiply all these parts by that number. 2 times 11 is 12, 22. 2 times 12 is 24, and 1 times 2 is 2. You can also divide it too. Alright, now let's move on to rotating our object. And for rotation, we can't just simply use part.orientation. We actually have to use CFrame, because this is the effective one that works. Orientation has a lot of problems with it. Now, for part.CFrame, since we're changing the CFrame, this will also change the position, since the CFrame is both position and orientation. So what I always tend to do, if I want to keep the position of the part, but I want to change the orientation, I have the parts position added onto the CFrame. And it's important that you put the parts position after the CFrame, since the parts position is a vector tree data type by itself. And if a CFrame is added by a vector tree data type, if the CFrame is first, then this vector tree data type will be added on as a position into the CFrame. And this works with every C-frame, but you can't use a vector 3 to add on to orientation. If you add a C-frame with a vector 3, it will always add on to a position, as if you're adding the positions vector 3 with the other vector 3 that you're adding. So, okay, now that I've gotten that out of the way, you want to have the parts position here because, yeah, it will reset the parts position if you make a new C-frame. So now that that's done, I'm gonna do CFrame.angles since this is how it works, and let's just set the orientation to 45 degrees on the x-axis. Play. It will move the x-axis 45 degrees up. Now, what I did here is math.rad. CFrame.angles takes radians as a measurement. If you know what radians are, you know. If you don't know, just put your degrees inside of this function here, math.rad. It will convert degrees to radians. And if you want the normal mathematical way, if you don't know, is your number divided by 80, or 180 divided by math.pi. And this does the same thing as this if you put number here. So as you can see, it changed the angles from, or the orientation from 0, 0, 0 to 45, 0, 0. If I want to change it to the y direction, I have it here. Run, moves it 45 degrees on the y-axis. If I wanted to move the other direction, I just simply put a negative. That's why earlier when I showed off how vector 3s work, it doesn't go from 180 to 360 because the opposite direction is in negatives, because 180 is half of 360. Therefore, they just made it so it's negative. Now, if you want to get a relative rotation, you can't simply just add two C-frame angles together. You have to use this method called ToWorldSpace. This is how I do it. And ToWorldSpace basically adds the two C-frames together without problem. So if I put this right here, it will add negative 45 and negative 45 together and makes negative 90. Alright, I forgot. Okay, that's an example of what happens if you don't add a new vector 3 of the parts position. Since C-frames is also the position, it will set it back to the origin by default if you don't have a position already put in your C-frame. So now that makes it negative 90 degrees. And the z-axis is weird. Whenever you change the z-axis using a script, it almost always changes the other two as a placeholder. If I do this, it worked normally. Okay, that's strange. Whatever. If you're working with the z-axis, it's kind of weird. The best way to master the z-axis is to do trial and error until you get the result you want. And that's how you move angles. I should have probably put this in the rotation section, but I'm just gonna put it here. But as you can see, let's set this back to 0. Let's say I rotate this 45 degrees, 60 degrees up, and then this way 90 degrees on the wheel. It will be pointing this way, right? But if I do this way first and then this way, the z-axis, the x-z-axis is different. As if I undo this and do this again, look closely, because this is what makes rotations so weird and complicated, because the order you put or rotate things will actually matter. Like if I rotate the x-axis first, it will end up like this. If I rotate this axis first, it'll go like this. And to solve that, when you use the ToWorldSpace and you just add these things together, oh yeah, I forgot. It's not part of this no more. Yeah, so basically, if you add these here, order of operations left to right, it will move the x-axis first, then the y-axis. If you want to move the y-axis first in a rotation, you have to just, I would just use ToWorldSpace and then add my y-axis component or my x-axis component. So in this way, it will first rotate it. It will work the y-axis first and then the x-axis, and it will produce a different result. Now we're moving on to the next part. Let's say you want the position in front of a part that has a weird rotation. Let's say we want the position one stud in front of this part, which is like, it should be around like here where I moved this part right here. That should be the one stud position. Let's say we want that position. Well, luckily there's a property that allows us to get it. It is called the CFrame.Look property, which returns a vector 3 position away from the block, or the position of the C-frame, which is the block, which is the position of the block, because we're using the C-frame of the block. Now, what I mean by that is the position property that is attributed to all parts is the vector 3 distance from the origin to, well, where it is in the map. When you do it from a part though, it would look like this. This is the vector 3 distance from this part from this part, and that is what LookVector returns. It returns, okay, let me just have the script show this out. See, if I run the script here, it will give you the position of this part in relative to this part, the vector 3. That's why I had to add the position of the part that I got the look vector from, because if I don't, let's see, I just removed this right here and replay it, it would, this vector 3, these components that are being shown is what it looks like, or what the vector 3 of the vector 3 distance in front of this part would look like. And as you can see from this gray number, the distance is 1 because the look vector gets the one stud distance away. So basically how to offset this is obviously just add its own position and it will fix itself. And let's say we want to get 10 studs in front of our vector, or in front of our part. We just have to multiply the vector and it will multiply the distance from 1 stud to 10 studs. And that's how you can extend your distance. And since the default distance is 1, multiplying it will basically just set it to whatever distance you multiply. You multiply 230, 230 times 1 is the distance of 230. Alright, time to discuss or explain how some common C-frame methods work. First up, ToWorldSpace. I used this in the rotation explanation. So the wiki explanation or the documentation explanation is returns a C-frame object transformed from object space to world space. My definition is adding whatever C-frame this is, which is currently 10 10 10 position 0 0 0 orientation, and adds it with the components of this C-frame, which is the position of 10 10 10. If you look up here, if you just add 3 numbers here, it will return a C-frame of a position and no rotation. It doesn't mention that, but it has 0 rotation. So if I do this right here, it adds 10 10 10 to each position. And let's say there's an orientation. Let's say I move this 90 degrees that way. And now I want to add an angle. So I change this to an angle, math.rad 0 40. Let's change it back to 0. See, -9 is canceled out by 90 degrees, and we add this. This should cancel out the rotation, and I screwed something up. Whoops, everything was in math.rad. So this should cancel. Oh wait, what? Why did I move the x-axis? Oh, it's because I put in x-axis. So yeah, it basically just added 90 degrees in the x-axis, as you can see right here. And rotation's weird because the order you rotate things matters. Let's say I want to move both the part and the rotation. I want to change both. Well, I'll just get part. Well, if I want to change the rotation first, I would do part.CFrame, change the rotation. Actually, let me just see what this does first. Okay, it does that. And if I want to change the position, I just change the position to whatever I want after. Let's just say part.position plus vector3.new 10, 10, 10. There, I changed both. The reason I didn't just like append it to the C-frame is because when I tried this earlier, for some strange reason, if I make a new C-frame, put 10, 10 here, and then ToWorldSpace, everything inside of here, it did some stuff I do. Oh, it did it normally. For some reason, it didn't work before, but I guess it works normally now. But if problems do occur, I recommend just moving each component, moving the rotation and the position separately. In order, the order does not matter for position. It matters hella for rotation. All right, it's time for part.CFrame.inverse. I'm just gonna show you what it does. As you can probably guess what it does. So 10, 10, 10 position. It's crazy. Oh yeah, let me try with orientation too. Negative. No, let's make a positive. Positive 45. Positive 45. Ooh, that's crazy. Negative 30, and it's weird because rotation is just weird normally. Yeah, you can probably guess what it does. And the wiki explanation, almost forgot to mention. Gets the inverse of the C-frame. That's crazy. Okay, next method. Alright, next up Lerp, and this is like the only last useful function or method that I think I would be worth showcasing. The other methods you can learn if you want. I think they're useless. I never had to use them. Alright, Lerp. It's a C-frame, Lerp. Is basically what it does. My definition is it moves this C-frame closer to your target C-frame, which I made it the black box again. And then you put in a decimal, which is percentage. So 0.2 is equivalent to 20%. If you just want to convert a whole number to percentage, just divide it by 100. So 20% divided by 100 equals 0.2. So I move it 20% toward the black box. And as you can see, since 20% of 10 is roughly 2, it moved it 2 studs closer to the black box. Make it go 50% closer, 0.5. It is now 0.5. I mean, the gray number should be 5. It's somewhere there. We moved 5% or 50% closer. And that's what Lerp does. The other methods are kind of useless. Alright, time for CFrame.lookat. This thing has been replaced by CFrame.new. All you gotta do is put in 2 vector3 values in here. And what this does is it makes this position, it returns a C-frame with it facing towards the second vector3. So if I change this part C-frame here, it will make it face the black part. As you can see, it's looking straight at it. And that's what CFrame.new does. Alright, the rest of these methods are, in my opinion, useless because I never had to use them, but I'll summarize them real quick. ToObjectSpace is the complete opposite of ToWorldSpace, but except part.CFrame is inversed, then it subtracts from the C-frame you put in here, and I forgot to put it as a C-frame. This, I don't know what you would use it for. Okay, or to normalize, I have no idea what this one does, but apparently Studio does it already. And you only use this one if you need to fix a C-frame for whatever reason. Get components, it returns all the numbers inside of a C-frame. 2 Euler angles, it's the same thing as CFrame.angles, but changes the rotation in a specific order. And I did not teach this in the rotation part because this is too much brain power for you guys to handle. And these two, they're the exact same. And what this one does, it already sets in order for you, so you don't have to input it. Same thing with this one. Alright, that's the end of the video. Alright, see you guys next time. Hope it was helpful.